Okay, these are the multiple choice questions from the mock exam. I'm starting with number 6, which is a non-calculator question. So this is the velocity, and you're supposed to find the total distance from 0 to 3. And so we have spoken about this, that the total distance would be from 0 to 3 of the absolute value of the velocity. Now, if you could do this on your calculator, you'd be done in 2 seconds, but you have to do this by hand. And we spoke about this once, which clearly many of you didn't remember, because no one seemed to know how to do this. Okay, so you have to consider, when is this positive, when is this negative? Because the inside could be negative, but it would turn positive because it has absolute value signs. So what you're going to do is you're going to take that middle piece, 16 minus t squared, and you're going to set it equal to 0. Okay, you're going to factor, and when you solve this, you're going to get that t equals 0 and t equals 6. Okay, so why is this important? Because that means that weird things are happening around 0 and 6. So, for example, when t is just plain 0, if you put 0 in there, you get 0, and so how could your distance be 0? So you want to look to the left of 0, because those would be the negative numbers. And you have to say, okay, so when t is less than 0, that's when you're going to get a negative number, inside the absolute value sign. So for example, if t was negative 1 and you put negative 1 into here, you're going to get negative 6 minus 1 is negative 7. Of course, absolute value turns into 7, but we're just looking for what would make that negative. On the other side of that, looking at t equals 6, if you choose a number that's greater than 6, then you're also going to get a negative, because let's say you chose 7 and you put it in here. You're going to get 42 minus, 7. 42 minus 49, and that's also going to be a negative number. So what you really need to know is, when is the inside of your absolute value going to be negative? And it's when t is less than 0 or t is greater than 6. But here's the good news, that the interval that you were given is from 0 to 3. So it's only negative if it's less than 0, so we don't care about less than 0. And it's only negative if it's greater than 6. So that means we don't have to worry about it being negative at all, and the whole thing is just positive. So you can just rewrite it without the absolute value signs. Okay, so let me just go back. That when you have the absolute value signs, you have to consider, what if it's positive, what if it's negative? But by setting it equal to 0, this whole little section here that we did, we determined that it's only going to be negative if t is less than 0, and first of all, t can't be less than 0 anyhow because of time, or if t is greater than 6. But we don't care about when t is greater than 6, because we're only interested in this interval right here, when it's between 0 and 3. So that means it's always positive. And you could test any number between 0 and 3 into the velocity, and you'll see you're always going to get a positive number. So once you know that, now this is going to be really simple, because now you could just take the antiderivative as it goes from 0 to 3. So I'm just going to erase a little bit, make some room. Okay, and I think I'll go to a different color. And so when I put 3 in there, I'm going to get there. Okay, when I put 3 in there, I'm going to get 6 times 9 over 2 minus 27 over 3. So that's what happens when I put 3 in there. When I put 0 in there, I just get 0, so I don't even have to worry about that. So I'm going to get 54 over 2, which is 27, minus 9, and that gives me 18, and that was choice D. Okay, and that completes number 6. Okay, this is number 8 from the multiple choice. So they're telling you that when t equals 4, you have 50 liters of oil. And what we're trying to find out is, how much more oil do you have from 4 to 15 hours. Okay, so we want the integral from 4 to 15 of R of t, and that will give us how much oil we got from the 4th hour to the 15th hour. However, remember you started with 50 liters, so to whatever you get to that, you're going to have to add the 50, okay? So they're asking you to use a right Riemann sum with 3 subintervals. So your 3 subintervals are going to be from 4 to 7, from 7 to 12, and from 12 to 15. So if they're telling you to use a right Riemann sum, that means you're just going to be making a rectangle. So we're going to have 3 different rectangles, and it's going to be length times width. Well, the length of the first interval goes from 4 to 7, which is 3. The next one goes from 7 to 12, that's 5. And the last one goes from 12 to 15, which is 3. Okay, so now we just need the height. So if we're using the right Riemann sum, if you have to choose between 4 and 7, 7 is to the right. So look at the table, and when t is 7, we have 6.2 liters. 6.2 times 3 is 18.6. Okay, for the next interval between 7 and 12, 12 is on the right. So if you look at the table, when t is 12, you have 5.9 liters. And 5 times 5.9 is 29.5. Okay, and for the last interval between 12 and 15, 15 is on the right. So when you look on the table, when t is 15, you have 5.6 liters. 3 times 5.6 is 16.8. So you're going to add those three numbers, and you're going to get 64.9. That means that you got 64.9 liters of oil in the hours between 4 and 15. But remember, you already had 50 to begin with, so you have to add 50 to that. And when you do that, you're going to get 114.9, and that is choice C. Okay, and that completes number 8. Okay, this is number 9. This is definitely a continuity problem. And so you have to find k so it's continuous at x equals 2. So we're going to do one thing at a time, and the first thing is to see if f of 2 exists. Well, when x is exactly 2, the function is equal to k. Alright, so it does exist. Now we're going to do the limit as x approaches 2. Now you have to do it from the left side and from the right side, but you actually only have to use one of these functions because whether you're coming from the left or you're coming from the right, you're not exactly 2. So that means you have to use this function right here. Okay, so the function is this. And we cannot use substitution because if you put 2 in there, you're going to get a 0 in the denominator. But you can see those cancel, and now you're left with this. Okay, now I can substitute, and I get 2 times 2 is 4 plus 1 is 5. In order for this function to be continuous, f of 2 has to be equal to the limit as x approaches 2. So this would only be true if k was equal to 5, and that was choice E. Okay, so this is number 10, and this is the area between two graphs. So the first thing I'm going to be thinking of is the integral of the top minus the bottom dx, so I remember what I'm looking for. Okay, now I don't know which one's on the top and which one's on the bottom, so I'm going to graph this. Now I know x equals 2 should be a vertical line at 2, so there it is. And I know that e to the x over 2 is going to be an exponential of some sort, but I'm not really sure, let's say, what that looks like. Okay, so let me consider some different values and make a table. So when x is 0, I get 0 over 2. E to the 0 is 1. So that means there's a point at 0, 1. Okay, if I choose 1, I'm going to be dealing with fractions, which I don't want to do. So I'm going to choose when x is 2. So when x is 2, I get 2 over 2, which is 1, and e to the 1 is just e. So remember, e is equal to 2 point something. So I'm going to have the point 2 and 2 point something. Hopefully, I remember that this is an exponential and that my function is going to look like this. So I'm looking for only in the first quadrant and in between that greenish kind of color and that orange color. So that means that this is the region that I'm looking for right in here. And I think it's pretty obvious from this picture that the top function is the e to the x over 2. So this is my top, and this is my bottom. I'm sorry. What am I talking about? I'm looking at the wrong thing. Okay, and my bottom is actually this line right here. Whoop. Right there. Which is just the line y equals 0. So now I can use my integral and say it's the top minus the bottom, which is just 0, so I'm not going to bother with that, dx. And now I need my integral. So it goes from 0 to 2. Okay, so now we just need to find the antiderivative of that. So I'm going to go to the next page for that. Okay, so that's where we started. I'm going to rewrite that x over 2 because I don't like dealing with that. I'm going to rewrite it as 1/2 x. Okay, so the antiderivative of e to the x is just e to the x. So I'm going to make a guess that the antiderivative is e to the 1/2 x. Okay, so I'm going to do a check, and here's how I do the check. I'm going to say, okay, what's the derivative of e to the 1/2 x? It better equal that thing right there. So the derivative of e to the 1/2 x is e to the 1/2 x, because e to the derivative of e to the something is e to the something, but times the derivative of the something. So I'd also have a 1/2 here. Well, if I look up here at my original, I don't have a 1/2 there. So I have to get rid of that 1/2. And I can do that by dividing by 1/2. So if I just divide that by 1/2, it will all come out nice. Okay, so that's my antiderivative as it goes from 0 to 2. Now, dividing by 1/2 is the same thing as multiplying by 2, so I'm going to rewrite that. And now I can substitute my values right in there. So first I'm going to put the 2 in there. 1/2 times 2 is just 1, so it's just e to the 1. And from that I'm going to subtract what happens when I put 0 in there. Okay, so e to the 1 is just e. E to the 0 is 1, and 1 times 2 is 2. So the answer is 2e minus 2, and that was choice A.